This is how we can represent an image in a computer. And that's my focus on this class, is that I'm not going to talk about the imaging modalities or how we are creating images, but I would like to talk about how do we save images and then talk about how we will process these images. If you have an image like this, each one of these boxes is called a pixel. And that pixel is represented usually by an 8-bit storage, and that is called 8-bit pixel. If it's an 8-bit pixel, 2 to the power 8 is 256. So I will have between 0 to 155 grayscales, with 255 being black and 0 being white. But I think this is an image of an eye, and you can see the darker the color, the smaller the value. So here for this image, 0 is black and 255 is white. We would like to look at images, open images using MATLAB, and look at the arrays of images and do some analysis. If we are dealing with a colored image, we have something called the red, green, blue color pixel vector or array. Any color that you can look at, it's a combination of the red, green, blue that makes them the color that we're looking at. Image formation, there are two parts of an image formation process. The first part is the geometry, which determines where in the image plane the projection of a point in the scene will be located. So if I'm looking at this, calculator, in my retina, there are projections of each point in the retina, right? And that's the plane of the image. So that's the geometry. So when we do image processing, you need to know where is the location of each element. So if you're looking at a CT scan, you need to not just identify the illumination and the grayscale, but also position on the plane. And that's the geometry of an image formation. And the other one is the physics of light, which is determining the brightness of the point in the image plane as a function of the illumination and the surface properties. So if you print an image on a smooth surface, you will see the color is different from if the surface is a little bit rough. So that's the physics of light. So what happens when you have a rough surface? You will have the rays of light projected, actually distorted, because they project in different directions rather than a flat surface. So these are the two things that before we do image processing, we need to understand. The geometry of the form, where are things located on a plane, a two-dimensional plane, and the other one is the physics of light, the brightness and the surface that you have your image on it. This is a simple model of image formation. We usually have light source and that illuminate on a surface, and that surface we have projections of light, and depending on the smoothness of the surface, if the surface is rough, you will have projections in all directions, and that's how the color will look blurry. But if we say that we have ideal reflection, illumination, that's your object, and then it will reflect on a sensor element in a camera. That's a chemical reaction for you to see the image. That's how we do that. So the scene reflects radiation toward the camera, and then the camera sends it's via chemicals on a film. Now we have digital images, and we deal with this in a different way. But that's the basics.